Hello everyone, this is lesson 3 of our trig unit. This is evaluating trigonometric ratios for angles between 0 and 360 degrees. It's quite a lengthy unit, so I might talk a little bit faster than normal. Since you first started learning about trig, you were working with standalone triangles. Now we want to put this into circles. And it's not to scare you, it's basically we can fit triangles inside of circles. Standard position, an angle in the Cartesian plane whose vertex lies at the origin and whose initial arm lies on the x-axis. So the angle is measured from the initial arm to the terminal arm. And I'm just going to draw a quick little diagram that will help us moving forward. So Cartesian plane has all 4 quadrants. We have quadrant 1, 2, 3, and quadrant 4. Okay. And 0 degrees, 90 degrees, 180, 270, and then the 0 degree is also 360 degrees all the way around. So we have the initial arm, and we will have the terminal arm. Okay, related acute angle, the acute angle between the terminal arm of the angle in standard position and the x-axis. So on the drawing, it would be right there. The principal angle is the whole angle between the initial arm and the terminal arm. Its value is between 0 and 360 degrees. Before we show you that, one thing it's good to know, any angle that's above 360 degrees means it's a full circle plus some. So, for example, sine 1 is the same thing as sine 361. Okay, the 361 is just one full circle and then another 1 degree. Okay, so I'm just going to quickly draw 4 graphs. We have quadrant 1, quadrant 2, 3, and 4. So if we have a terminal arm in quadrant 1, this is your principal angle. In quadrant 2 is your principal angle. Quadrant 3. So you can see the principal angle is the angle starting at 0 degrees and goes all the way to your terminal arm. Negative angles, an angle measured clockwise. So you notice before we're always moving counterclockwise. From the positive x-axis, so an example of this, if we have a negative 20 degrees, so we will move 20 degrees this way. So the terminal arm is actually, the principal angle would be 360 minus 20, so 240 degrees. Okay, if an angle is in standard position, we can work out each of the angles and in the other quadrants. Okay, so we have our initial arm here. So if we have this terminal arm, then we have our principal angle, and we also have the related acute angle. The related acute angle, again, is the terminal arm to the closest x-axis, right? It has to be an acute angle, so in between 0 and 90 degrees. So if your terminal arm is in quadrant 2, we can solve for the related acute angle through 180 degrees minus the terminal arm. We can also solve for the terminal arm if we know the related acute angle by 180 degrees minus the related acute angle. Okay, in quadrant 3, here's your principal, and the related is within that because that is the closest distance from the terminal arm to the x-axis. So here, to find the related acute angle, it is your principal angle minus 180, and to find the principal, it will be 180 degrees plus your related acute angle. And then finally in quadrant 4, your related acute angle is here. So to find the related acute angle, it's 360 degrees minus your principal, and to find your principal, it's 360 degrees minus the related acute angle. Okay, let's consider a circle centered at the origin. If you chose the point 3, 4, 1, 2, 3, on the circumference of the circle. So imagine there's a circle, it'll go around like this. And we have this point that's on the circumference of the circle. We can determine the primary trigonometric ratios for the principal angle. So if we made a triangle out of this point, we know that it has an x value of 3, a y value of 4, and we can find what we call the r value. And we do that because this is a right angle triangle through Pythagorean theorem, right? So r squared equals 3 squared plus 4 squared, 9 plus 16. So r is the root of 25, and since we can actually find the root of 25, it is 5. So that's called r because it's a radial arm. So terminal arm and radial arm mean the same thing, but it is the radius of the circle. Okay, now it wants us to find the primary trig ratios, which we know are sine, cos, and tan. Okay, and through our knowledge of SOHCAHTOA, we know that sine is opposite over hypotenuse, so 4 over 5. Cos is adjacent over hypotenuse, 3 over 5. And tan is opposite over adjacent. Okay, determine the related acute angle and the principal angle to the nearest degree of the example above. So for this, we could choose any of our primary trig functions. We're going to choose tan equals 4 over 3. So we need the angle. And this is, when you do this, it's going to give the related acute angle because we're working with triangles. And it's always going to be the angle within the triangle, where the principal angle doesn't necessarily have anything to do with the triangle. It could be the angle outside of your triangle. So this will give us a related acute angle. And to find that, it is the tan inverse of 4 over 3. And this gives us a related acute angle of 53 degrees. Now, because our triangle is in quadrant 1, the related acute angle and the principal angle are the same thing. Okay, same in quadrant 1. If you chose the point 3, 4, okay, so redraw my Cartesian plane. Now we have point 3, 4, so over 3, up 4. It's negative 3, 4. And we don't, because it's 3 and 4, we don't have to do Pythagorean theorem again. We know that it's 5. We just did it. Determine the primary trig ratios and the related acute angle and the principal angle. Okay. So the primary trig ratios, again, sine, cos, and tan. So sine is 4 over 5. This time cos is negative 3 over 5, and tan is negative 4 over 3. Okay. So we are going to find the related acute angle. And this time let's use cos. Okay, so the cos RAA equals negative 3 over 5. So we're just going to work with 3 over 5, and I will explain that later on in the lesson. So the related acute angle is the cos inverse of 3 over 5, and that tells us again that it's 53 degrees. But this time, because our principal angle is not, our terminal arm is not in quadrant 1, we actually have to do something to figure out the principal angle, and this is where we move back up. So it's in quadrant 2, so we go back up here, look in quadrant 2 to figure out the principal angle is 180 degrees minus the related acute angle. So we have 180 degrees minus the related acute angle. So 180 minus 53, and we get 127 degrees. For each ratio, use a sketch to determine which quadrant the terminal arm lies and the value of the related acute angle and principal angle. Okay, so tan 220, so 220 degrees is right about there. So we're going to find the principal angle and the related acute angle. So the principal, actually, we already know is 220 degrees. Okay, it's quadrant 3. In quadrant 3, to find the related acute angle, it is the principal angle minus 180 degrees. So 220 minus 180. So related acute angle is 40 degrees. Okay, in this next one, it's saying go minus 100. So that is the negative, and we're counting clockwise. So we start at 0, 100 degrees is right there. Sorry, let's do that in, so we did minus 100, and that means our principal angle, so 360 minus 100 will be 260 degrees, and the related acute angle is here, again in quadrant 3. So it will be the same formula of the principal minus 180, 260 minus 180 equals 80 degrees. Okay, and finally our last one, cos 300. 300 is in quadrant 4. RAA is here. And to find the RAA in quadrant 4, it is 360 degrees minus the principal. So we get a related acute angle of 60 degrees. Okay, the cast rule. This rule is an easy way to remember which trig ratios are positive in which quadrant. Okay, so we have quadrants 1, 2, 3, and 4. Now what we need to remember is cast, C-A-S-T. Okay, this tells you which ratio is positive in which quadrant. In quadrant 1, everything is positive. That the A stands for all. In quadrant 2, only sine ratios will be positive. In quadrant 3, only tan ratios will be positive, and in quadrant 4, only cos ratios will be positive. And I'll show you why that is. So I just drew a triangle in quadrant 1 and a triangle in quadrant 2, and do the same here. Okay, so a triangle in each quadrant. So instead of hypotenuse, opposite, adjacent, we are going to use y, x, and r. This would be negative y. R is always positive. So in quadrants 1 and 4, you can see that the x is positive. In 1, the y is positive. In 4, the y is negative. In quadrants 2 and 3, x is negative. Okay, so if I made a quick table, we have sine, cos, tan. And we have quadrant 1, 2, 3, 4. Okay, so we're going to have the ratios for each of them. So in sine, we know it as, again, opposite over hypotenuse, but when we're using the letters x, y, and r, it is y over, actually I'm going to change colors, it is y over r. Cos is adjacent over hypotenuse, or x over r, and tan is opposite over hypotenuse, so y over x. So you can see here in quadrant 1, everything is positive. When we go to quadrant 2, sine, again, y over r, because they're both positive, but cos, the adjacent, the x is negative. So it's actually negative x over r. And tan is y is positive, but x is negative, so it'll be negative y over x. Okay, down to quadrant 3. Sine, the opposite is negative y. The adjacent is negative x. But because it's negative y and negative x, we know that a negative divided by a negative is a positive. So tan will be positive in quadrant 3. And finally, in quadrant 4, sine, we have negative y over r. We have positive x over r, and we have negative y over positive x. Okay, so again, it's telling you which 2 quadrants each of the primary trig ratios are positive and which one they're negative. So again, example, sine is positive in quadrants 1 and 2, hence the AS. Cos is positive in 1 and 4, and tan is positive in 1 and 3. Okay, number 4, determine the values of the angle if cosecant is -2 times the root of 3 divided by 3, where the angle is between 0 and 360 degrees. So we know that cosecant is not a button on your calculator, so we need the reciprocal, and cosecant's reciprocal is sine. And of course, the reciprocal means we will turn it upside down. Okay, I'm just putting the negative sign in front of the fraction because we don't actually use the negative in our inverse. Okay, and remember, this is really telling us the related acute angle. So it's the sine inverse of 3 over 2 root 3. And our related acute angle is 60 degrees. So why did I get rid of the negative in the fraction? Well, that is telling us where to look in the quadrants, which quadrants to look in. Okay, so because our answer sine theta equals a negative answer, we need to know when sine is negative. And by the chart above, sine is negative in quadrants. So sine is negative in quadrants 3 and 4. Okay, so this question is asking us to determine the angles when sine is negative. So from here, we're going to work in quadrants 3 and quadrants 4. We know the related acute angle. So to find theta, or the principal angle in quadrants 3, our chart way above told us that we need to do 180 plus the related acute angle. So 240 degrees works. And in quadrant 4, we know for the principal angle, it's 360 degrees minus the related acute angle. And 360 minus 60 is 300. Okay, so 240 degrees and 300 degrees are the angles that work with cosecant that will get an answer of -2 times root 3 divided by 3. Okay, and finally, we're going to do the same thing here. We're going to look for the angles and see what quadrants they work with. Okay, so the RAA for number 1 is the tan inverse of 1.2678. So that gives us a related acute angle of 52 degrees. Now, this was tan theta equals positive 1.2678, and tan is positive in 1 and 3. Okay, so in quadrant 1, we don't really need to do anything because the related acute angle and the principal angle are the exact same thing in quadrant 1. But for quadrant 3, to find the angle is 180 degrees plus the acute angle. Okay, so the angles that work with tan to get positive 1.2678 are 52 degrees and 232 degrees. Okay, secant, again, not a button on the calculator, so we need to reciprocal. So the RAA and the reciprocal of secant is cos. And we need to find the reciprocal, so it's 1 over 4.4444. So we get a RAA of 77 degrees. the 4.4444 was positive. Cos is positive in 1 and 4. So again, in quadrant 1, it's the same thing as the RAA. In quadrant 4, theta equals 360 minus the angle. (283 degrees). Okay, we'll just separate these. And the last one is the cos inverse of 0.4444, which gives us 64 degrees. Now it was cos theta equals negative 0.4444. So this time we want to know when cos is negative. Well, if it was positive in 1 and 4, it's going to be negative in 2 and 3. Quadrant 2, the principal angle is 180 plus RAA. So we get 244 degrees. And in quadrant 3, oh, my mistake. That was quadrant 3. Quadrant 2, it's minus RAA. Okay, quadrant 3 is plus RAA. Okay.